Graph the equation on paper and then choose the correct graph on the right. On this problem, I would definitely plug this in my graphing calculator, right? And I would look at the one that matches. Keep in mind that your window is going from, on your x-axis, is going from +5 or -5 to +5. And if you want it to look exactly the same, you would change your window. So I'm not going to go to the graphing calculator for every one of these, but I do want to kind of remind you what that looks like. So if I go to y equals, and I'm typing in alpha, y equals, to type in my 1/4 raised to the x power. Okay, so if I want to change my window to match, I would hit window and I would change this from -5 to +5. I'm not going to mess with anything else except for the minimums and the maximum. So it would look like what it looks like on that graph. I'm sorry, I must have something else in my y equals. Sorry about that. So when we look at the graph, we've got an exponential function that is decreasing. It is very easy to see the right answer is what? I'm kind of scared at this point, but C, right? Looks like C to me. It was decreasing. It didn't go below on B. It's kind of going below the x-axis, and it didn't do that. Okay. Question number 2 says, sketch the graph of the function and check the graph with the graphing calculator. Before doing so, describe how the graph of the function can be obtained from the basic graph of a basic exponential function. So, I mean, if this is me and I'm taking this test, I'm probably going to go, okay, I'm probably going to say, well, what is the basic function? So to me, the basic function is just 2 raised to the x power. You kind of take everything, strip everything off of this. I'm not saying A is the right answer. Let me erase that because A is, I don't know if A is the right answer. So the first thing I want to do is kind of go, well, what does the regular function look like? And we think that that regular function is y equals 2 to the x. So if you plugged in, I don't have to plug in a lot of things to this, but if I plug in a 0, 2 to the 0 would be 1, and I could get these off my graphing calculator. 2 to the first power is 2, 2 to the second power is 4. And so my regular function is going to look something like 0, 1, 1, 2, 2, 4. So it's in this black color. And it may be a good idea for you to kind of go, just to make sure you're doing this right, maybe go and plug that into your y equals on the first one. And the other function we're talking about, just going to do it in a different color, is y equals 2 to the x minus 1. So I could absolutely go to my graphing calculator and say, well, pick some of the same points here, and it would tell me the values. If I do this by hand, I would plug in 0 for x. So 0 minus 1 is -1, and 2 to the -1 is equal to 1/2. If I plugged in 1 here, that would be 2 to the 0, which is going to give me 1. If I plug in a 2, it's going to give me 2 to the first, because 1 or 2 minus 1 is 1. And 2 to the first is 2. So if I plot these points, I would have a point at 0, 1/2. I would have a point at 1, 1, and a point at 2, 2. Okay, it kind of going to do something like this. Okay, and so we should be able to kind of tell what the right answer is. And it is C, because we're starting with the graph of y equals 2 to the x, and we're shifting that graph 1 unit to the right. You can kind of see that that's been shifted by 1. We also know it should be the opposite of whatever's happening up here, right? So you can see that both ways. Fine to get the table off the graphing calculator, but okay. Number 3. Sketch the graph of the function and check the graph with the graphing calculator. Before doing so, describe how the graph of the function can be obtained from the graph of a basic exponential function. What should this +3 do? At the top, so with the exponent, so it's gonna, it's gonna go left or right, and it's opposite of what you think. So if it's a +3, it should be to the left 3. And this -5 part should be to the, should be down 5. Exactly what we think it's gonna be. We are starting out with the graph of y equals 2 to the x power. We are going left and down. You can absolutely, I'm not going to do this here, but you can absolutely use the same strategy I used before and make you a graph y equals 2 to the x power and look at what's happening there. So this one would be y to the equals 2 to the x. We don't have to graph that one, but we do have to graph the other one. Y equals 2 to the x plus 3 minus 5. Okay. Remember that on your homework, this is that tool. Basically, you just go put a point at 0, 1, and then you shift it where you need it to go. You make sure that you put your bases too when you graph this, right? Just reminding you about this stuff. So I'm just going to pick a couple of points. I'm not going to, let's just do 0, 1, and 2. I can do this probably faster than going back to my calculator. So if I plug in a 0, 0 plus 3 is 3. So 2 to the third is 8, and 8 minus 5 is 3. So I would have a point at 0, 3. Okay. If I plug in a 1, 1 plus 3 is 4. 2 to the fourth is 16. 16 minus 5 is 11. And I think I'm already off my graph here, right? 111, it's going to be way up here. Let's go backwards a little bit. Let's plug in a, let's go get a -3. -3 plus 3 is 0. So 2 to the 0 is 1, and 1 minus 5 is -4. So we would have a point at -3, -4. Kind of does something like this. It's going to get really, really close to that -5 line. So you can tell that it's kind of been shifted to the left some and pushed down. If you have a lot of trouble seeing that, graph both of them on the graphing calculator and you can see it a little bit better. Suppose that $68,000 is invested at 6.5% interest, compounded quarterly. Okay, find the function for the amount to which the investment grows after T years. Found the amount of the money in each one of these accounts. So this was that formula that we had where we said the amount is equal to the percent, not the percent, the principal, and then we did 1 plus the rate divided by the number of times it happened per year times the number of times it happened per year times the time. How many years went by is usually what it is. Okay. So in this problem, we would say, okay, our amount is equal to, we're putting in $68,000 to begin with. 1 plus the rate, which we do not want as a percent. So we want to make sure we do 6.5 divided by 100, and it's going to tell us that is 0.065. So 0.065. We're compounding quarterly. So what are we going to divide by? How many times does quarter happen in a year? 4 times. And so we're going to multiply that by 4 times T, which is going to be the amount of years that go by. Okay. So here is my function that I want to use. I'm making sure that when they they're wanting you to before you write it, they're wanting you to figure out what all this stuff is together. So you would type this part in your calculator and get 0.065 divided by 4 is going to give you what this decimal part is. raised to the 4t. So that's what they're wanting you to write in right here. Is everybody okay with that? So you just type in this middle section and it's going to give you this. That's what you should put right here. If I want to find 0, 4, 7, and 10 years, the fastest way to do that is going, and they're wanting to round it to the nearest dollar, which is nice. It's just to type it in the graphing calculator. So I would go to y equals, clearing this out, we've got 68,000 times 1.01625 raised to the 4t. So 4x for us. I'm going to hit second table. I'm going to look for the years that they told me to look for, which are 0. Sorry. 0, 4, 7, and 10, and I'm going to find the answers there. So here, 0 would be 68,000, 4 would be $88,007, and they are wanting me to round that to the nearest dollar. So these are already rounded for me. Scroll down to get what I need. So the answers for this one are 68,000. $88,007, $106,789, and $129,578. Questions about that one? You need to make sure you write down this formula, and you kind of need to know what goes there for each thing. We've worked something like this before. Melissa's 6th birthday, she gets a $5,000 CD, and we talked about, man, let's have a rich grandma somewhere. And she gets 6% interest, and it's compounded semi-annually. Okay, so if the CD matures on her 10th birthday, how much money will be available? So we're using the same formula that we used above. So we would say, well, we're putting in 5,000. So the amount is going to be starting out with $5,000, 1 plus the rate. Well, the rate is 6%, but we don't want that as a percent. We want it as a decimal. So we would put in 0.06, 5 by 100. And this is happening semi-annually, so twice a year. And then raised to the n, which is how many times it happens a year, so twice a year. But this time we do know that we're trying to figure out what she's going to have on her 10th birthday. So how much time is going to go by from her 6th birthday to her 10th birthday? That's why we're putting in 4 right here. Okay. The graph, if you can make this look like this in the graphing calculator, it absolutely can handle all this at one time. Or you could figure out what the middle of in this parentheses is, and that might make it a little bit easier for you to type in. Just depends on what you want to do. But on number 5, and we round to the nearest cent is what it's given us. She should have $6,333.85. Is there anybody who needs to see me type it in the graphing calculator? I don't mind doing that. I don't want to waste your time if you don't need me to. Okay. Find the logarithm. There is a lot of different rules you can use for this. If this is me, the first thing actually it wouldn't be, because never mind. If I'm a student, the first thing I'm going to do is I'm going to type this in my graphing calculator and see if it gives me the answer, because it could be that easy that I could just get this on my own. I know that this is saying 10 to what power is 0.01. So I can know the answer in my head. But more than likely, you're just going to be able to go to your graphing calculator and go, remember that if you want to, it's already the log base 10. So we don't actually have to type in the 10. We can just use our regular log button and type in 0.01, and we can hit enter, and it tells us -2. Okay, so making sure that they do want the answer written just like that. So that's it. -2. number 7. Find the logarithm, and it's got log base 3 of 3 squared. Okay, I mean, this is saying 3 to what power is 3 squared? It's 2. These are the same, but you absolutely can type this in the graphing calculator by going to, this time you're gonna have to go to math. You're gonna have to pick that log base because you want to be able to type in 3 and then 3 raised to the second power to get it to look like what it's supposed to be looking like, but the answer is 2. So most of these like this, you're going to be able to do in the calculator. You just got to make sure you're able to function the calculator correctly. So this is 125. And this is equal to x. So I'm just 125 raised to the what power is equal to 5. That's what that means. Okay, so and it type a fraction. So we want to be careful if we go to our graphing calculator that we actually get a fraction and not a decimal. So I would go to math, log base, and we're doing 125, sorry. 125, 5 here, enter, and it says 0.333. I know that that's 1/3, but you could also go and highlight it and hit enter and say math. We want it to change it to a fraction for us. So we hit enter and it, well, that didn't work. I wonder if I had my setting wrong. But usually you can get that to turn it back to a fraction for you. So I'm not going to try to fix that right now, but 0.33333 is 1/3. Does bother me though. I wonder if I did it up here. Hold on, I'm gonna have to try one more thing. So second log clear math. Because I wonder if it's already cut off the page. That's why it's doing that. I don't know. This one is different than also my graphing calculator that I have, my handheld graphing calculator. So sometimes, okay. So if I didn't copy it, it would work. So it's fine, 1/3. So I just hit math, enter, enter, got it to change it to a fraction. Just want to make sure you're able to do that as well. So it does work, and we can just say, so this is 1/3. This means 18 to what power is equal to 1. You should know that that is 0. But calculator's going to do that for you. You can just go math, scroll down to your log base, type in 18. Okay, so it's fine. I mean, the calculator is there for you to use, so it's fine if you're dependent on that for this. This says, this, however, is not a calculator problem. It says to convert this to a logarithmic equation. So remember that we started with this, we skipped whatever the middle number is, and we come back to it. So we would say the log base 10 of 100 is equal to 2. You got to do your numbers in that order. It's kind of the trick to this. I am making sure that the way they want you to type your answer in, because that's important too sometimes. Yeah, they're putting the base 10 there. So that's exactly what you need to type in. We would start here, skip it, come back to it, and they, on number 11. So the natural log, because we're talking about E, base E of P is equal to -3. And for whatever reason, I don't know why they're leaving. I mean, we know it's an understood E when we're using natural log. Maybe that's it, but they didn't leave the 10 off here. But I just want to make sure, like they're writing the answer as natural log of P is equal to -3. They are leaving that E off. I don't know that it would be wrong. It would count it wrong if you didn't, but that's how they're typing the answer in. Okay. Convert to an exponential function. Now we're going backwards, still starting at the first number, skipping the second number, coming back to it. So 2 to the 4th is equal to 16. start, skip over one, come back to it. So m to the negative x is equal to v. Questions about those? Use a calculator to find the natural logarithm base e. This is a matter of typing this in your calculator. So just to make sure that everybody knows where that button is, we're taking the natural log, which is on the first row, 485.4. Hit enter, and it says that they want us to round to 4 decimal places here. So .185, and sorry, I read the wrong problem. Round to 3 decimal places, right? No, it says to round to 4. It says as needed. So that would round up. Okay, I see now. Because this 7 is going to make the 9 round up to a 0, which is going to make 4 round up to a 5. So they left it as, but it would be fine if you did this. It would be 6.185, and there would be a 0 if you're actually going to put the 4th decimal. Y'all okay with that? Okay. Find the logarithm using the change of base formula. I don't care how you find the logarithm if you just type it in like that, but sometimes if it asks you to use the change of base formula and you don't, it can be off like by a little tiny bit. When we're having to get down to 4 decimal places, then you might want to actually use the change of base formula. You can check it by just typing it in, but the change of base formula is take the log of the bigger number divided by the log of the smaller number. That's it. It's not something that's complicated. So the log of 90 divided by the log of 6. And you may get the same thing when you should get something very, very close if you don't get the same thing when you just type this in, but 2.5114. I just want to caution you about that. Number 16. Questions about that? I'm going through these fast because they're not real complicated. We're typing these in the calculator. So if you need anything, just let me know. Express this as a sum of logarithms. So that means they're wanting us to stretch this back out. So multiplication goes with addition. So log of 11 or log base 11 of 11 plus the log base 11 of 121. Express this as a product. All they're wanting you to do is use that product rule and move the 5 to the front. So 5 times the log base 2 of y. That's it. Rewrite this as sums or differences of logarithms. It's all multiplication. So that means it's all going to be addition. It's all multiplication. It's all addition. And they're going to want you to move the exponents to the front. So the log base b of x to the 8th plus the log base b of y to the 7th plus the log base b of z. The 8 would move to the front. We're using the product rule. That 7 is going to move to the front. So the 7 times the log base b of y. And then we didn't have anything. The z didn't have an exponent, so it's going to be that. Number 19, express in terms of sums and differences. So I do see 2 things multiplied on the top of the fraction, and I see 2 things multiplied on the bottom of fraction, and I see division in the middle. So it's going to be something added, something subtracted, and that something added on the bottom, because here's the top of the fraction right here. The division is the minus, and the bottom of the fraction's right here. So we would have the log base b of p to the 3rd plus the log base b of q to the 7th minus the log base b of m to the 3rd log base b of b to the 9th is where I would start. The exponents, well, take away the parentheses next. So this parentheses doesn't have anything in front of it. So we would just jot down what we already have. This minus needs to go with both of these. So minus log base b of m to the third, minus log base b of b to the ninth. This 3 is going to move down front. The 7 is going to move down front. This 3 is going to move down front. And this is special because these two things are the same. So when this 9 moves down to the front, it's just minus 9 because log base b of b is just 1. I want to make yourself a note. Log base b of b, that is just 1. So it just ends up being minus 9. And so the right answer on 19 ends up being that D. Y'all okay with that? I feel like I was in a hurry. Do I need to give you more time? Try to leave that one up there still. On number 20, we are subtracting, and so that is a division. So we are taking the natural log of both sides. So we have x squared plus 12x plus 35 on the top and x plus 7 on the bottom. What you need to do on this one is factor it to make sure nothing can cancel out. So you could use your quad program to factor it if you want to and work backwards, or you can just think what multiplies to 35 and adds to 12. So x plus 5, x plus 7. If you had have used your quad program right here, you would have got -5 and -7, and you would have switched that, right? And so there's nothing to factor on the bottom. These will cancel. And so D. This problem is very similar. We are subtracting, so that is a division of x squared plus x minus 12 over x squared minus 16. Once again, you could use your quad program, and it would tell you the bottom would be -4 and +4. And so you would say x minus 4, x plus 4 when you factor it, because you're trying to see if anything cancels out. You could use the quad program on the top. Just make sure you do the opposite of whatever it is. So in my mind, I'm not using quad program. So I'm thinking of what multiplies to -12 and adds to x. I mean, adds to 1. So x plus 4, x minus 3. If I had have used the quad program, I would have gotten -4, and I would have had to change it to +4. And I would have gotten +3 and had to change it to a -3. So these cancel. So we would actually type log of x minus 3 over x minus 4. That would be the answer. And that log is it's not on the bottom or the top, it's just kind of out in the front. Okay. Y'all good? Okay. Solve for x. So remember, when it's like this, the goal is to try to get the same bases. So what I would like to see is if I've got 4 to the 9x, is it possible for me to change 16 to be 4 to the something? Because that's the easiest way to solve this. If I can get 16 to be 4 to the something, and I absolutely can, 16 is 4 squared. So that means that 9x is equal to 2. So divide by 9. So x is equal to 2/9, and it does want you to leave the answer just like that. Questions about that? Number 23 says solve the following exponential equation. First thing you want to think is, can I get 5 to be 3 to the something? No, you cannot. So you have to use logs to solve this. So you're going to take the log of 3 to the x is equal to log of 5. This is going to make me be able to bring that x, using that power rule, I can bring the x down front. So I can divide by the log of 3. And so we're going to get x is equal to the log of 5 divided by the log of 3. And they want us to round to 4 decimal places. It's going to be 1.4650. Okay with that? It would be really nice if I could get 0.13 to say e to the something, but I can't. So I'm going to have to take the log of both sides of this. And since we're using e, I'm going to use the natural log. That's going to let me bring this down front. And so negative 0.89t natural log of e equals natural log of 0.13. The natural log of e is just 1. So it kind of cancels out and goes away. We talked about that a lot during the last class too. So we want to divide both sides by negative 0.89. And that's going to give you t is equal to 2.2924. Okay. It'd be really nice if I could get this 12 to be 4 to the something, but I cannot. Kind of scoot this over. So I'm going to need to use logarithms to work this problem. So I'm going to take the log of 12 to the x equals log of 4 to the x plus 3. That lets me move my powers to the front. So the x times the log of 12 is equal to x plus 3. And I put it in parentheses because I'm trying to remind myself that the whole thing's getting multiplied by the log of 4. Okay, so what we want to do with this problem is get all of our x's on the same side. And I can kind of split this up a little bit and decide if I want to make this. So let's go back. Let's say, so I could say that this is the x times the log of 12 equals, I can kind of use the distributive property and say x log 4 plus 3 log 4. Y'all okay with that part? Separating those out. And then I really want to get my x's on the same side of my equal sign, because it's really hard to isolate if they're on 2 different sides. So x log 12 minus x times the log of 4 is equal to 3 log of 4. I can, since both of these have an x in the front, I can pull that x out and get x times the log of 12 minus the log of 4, because what I did was take x out of both of those terms is equal to 3 times the log of 4. We're going to divide both sides by that log of 12 minus log of 4. Just going to make this side cancel out. And we're going to have x is equal to the 3 times the log of 4 divided by the log of 12 minus the log of 4. And that comes up to be 3.7856. If you round to, what do they want? 4 decimal places. That one was kind of complicated. Y'all okay with that? Try to leave it up there a little bit longer in case you still need to copy it. This one's not as bad. If you're given a logarithm and you're trying to solve it, you want to write it as back in exponential form. So I'm saying 5, skip over the middle part and come back to it. So I'm rewriting it as 5 to the second power is equal to 4x minus 7. I'm writing it as an exponent. Then I would say, well, 5 squared is 25. Add 7 to both sides, so 32 is equal to 4x. Divide by 4. So we're going to get x is equal to 32 divided by 4, which is 8. Says to solve this logarithmic equation. So this one is separated right now. They're both log base 4. So I would probably put this back together. As crazy as that may sound. So if I put it back together, I'm going to have the log base 4. Since I'm dividing, it would be s plus 21 over s plus 5. I'm going to put lines through my s's so that they don't look like 5s. Is equal to the log base 4 of s. If these are both the log base 4s, then that must mean that s plus 21 over s plus 5 is equal to s. I just remove the logs off of there because they're the same. So they must be equal to each other. So the next thing that I would do is, I know that I can't have that. I need the bottom of this fraction gone over here. So I would multiply both sides by s plus 5. These s plus 5s are going to cancel out, and I'm left with s plus 21 is equal to s times s plus 5. This s can get multiplied by both of these things. So s plus 21 is equal to s squared plus 5s. This is definitely quadratic because I've got an s squared. So I want to solve it for 0. I want to subtract s from both sides of my equal sign. That's going to get me 21 equals s squared plus 4s. Then I would subtract the 21 from both sides, which is going to get me s squared plus 4s minus 21 is equal to 0. So at this point, you can use your quad program, right? You could, it's just asking you to solve this. So you absolutely could use your quad program. If you use your quad program, you're going to get, those people following me on Zoom, what do we get when we use our quad program? What are the solutions to this? If I'm solving this by hand, I'm looking for something that multiplies to negative 21 and adds to 4. So myself a little bit more room. S. So plus 7 minus 3. So it would be the opposite of those, negative 7 and 3. Now, one small fact, you can't take the log of a negative number. Okay, so when I go back up here and I look at these, when I try to plug in 3 is going to be fine. on this. So 27, 3 is going to be fine. -7, when I plug in -7 plus 21, well, that's still going to be positive. -7 plus 21 is positive. -7 plus 5 is not positive. It's -2. And if I plug in a -7 for this, it's not going to work. This choice doesn't work because when you plug it back in, you can't take a log of a negative number. So that's why. Um, 28. This is an addition. So when I solve it and put it back together, I'm going to change it back to 1. So I'm going to do a multiplication. So I just squished them back together, made it a multiplication. If we do FOIL on this, actually, let's don't do FOIL yet. Let's change it to an exponent. It wouldn't matter if you did FOIL, but let's change it to an exponent, get rid of the log. So 2 to the 5th is equal to x plus 7 times x minus 7. So I almost said 2 to the 5th was 25, and it's definitely not. Brain's getting tired, I guess. So 2 to the 5th, 2 times 2 times 2 times 2, 32 is equal to, if we use FOIL on this, we're going to get x squared minus 49. I'm not going to do the whole FOIL. The middle cancels out, right? It's the difference of squares. Anybody need me to work the whole FOIL? This is not hard to solve from here because I can use the quad program, but I could just add 49 to both sides and get 9 and 2, 81. So x squared is 81. We would take the square root. And so we would get x is plus or minus 9. Be careful. We know the positive 9 is going to work, but anything that makes anything up here negative is not going to work. So if you plug in -9, -9 minus 7, that's going to be negative. It's not going to work. So it's the positive 9. The -9 does not work. Okay. This is your amount is equal to the principal times E times they use K for the rate, sorry, KT. This problem says I'm starting out with $13,790. It's invested at a rate of 5.6% per year. So I know I'm going to have to divide that by 100. But that's what I'm going to plug in. 0.056 is going to get plugged in for K. I don't have a time yet, but that's going to be, it's compounded continuously. So I know this is why I'm using this formula. It's compounded continuously. So this is going to be what your equation is. Okay, and we can type that in the calculator to get the answer. And remember that we want 1 year, 2 years, 5 years, all that's good stuff. Class time is almost over with. If you need to sneak out, I completely understand, but just please be quiet while you do that. I will post this video today. 0.056. I just want to remind you of this because I know y'all saw where I forgot about it the other day too. So 13,790. So if I want to round it to 2 decimal places, remember that it's already rounded over here, and you have to actually scroll over and highlight it to get the extra decimal places at the bottom. So if you're going to use the calculator, you got to do that part. The answers end up being $14,584.27, $15,424.29, $18,245.96, $24,141.77. Doubling time. So we want the amount of time it's going to take this thing to double. So we would say, well, what is 13? We want to take 13,790 and we want to multiply it by 2 to figure out how much we would have if it was doubled. and we get 27,580. Well, we're still starting out with 13,790. Our rate is still 0.056. We don't know what our time is. That's what we're trying to figure out. How much time will it take for this to double? So we're going to divide both sides. That's going to be 2 is equal to e to the 0.056t. We are going to take the natural log of both sides so that we can get that t to move down for us. The natural log of e is 1. So we don't really need that. We're going to divide both sides by 0.056. And we're going to get our answer of, it rounds to 12.4, the one that one decimal place, 12.4. Okay, last problem. I lied. Okay. So, and we worked this problem, I want to say the exact same problem yesterday, or Monday class, but they want us to use these 2 years, 1960 and 2012. There are 52 years that go by here. They want us to find K. So to find K, the ending part was 44.6 in 2012. That's what we ended up with. So we have some decay happening. We started out with 70.7. And e to the, we don't know what K is, but we do know that T is 52 years. Okay, so you're going to divide by 70.7. 44.6 divided by 70.7 is 0.630834512. And that's equal to e to the, I just like putting the 52 in the front of the K, but it doesn't matter which one you do. I need to take the natural log of both sides to get that 52 to be able to move down front. Natural log of e is 1. That kind of goes away, and we're going to divide by 52. Comes out to be negative 0.00. Sorry, I didn't remember getting this before. Maybe it's slightly off, but negative 0.00885, and it keeps going. And it wants me to round to 4 decimal places. So this is important. When you write K up here, you don't put the negative part. You're just going to put 0.0089 when we round. But when you write the formula, you do put negative 0.0089. When you substitute it in, that's when you change it to your negative answer. So please remember that. You don't want to get a little thing wrong like that. And so this part is still going to be 70.7. Okay, if we want to know what happens in 2015, we're going to say, well, our table started in 1960. So 2015 minus 1960 is 55. That's what we would plug in for T. And 2018, you subtract 1960, that's 58. That's what you're going to plug in for T. When you plug these answers, so you're going to say 70.7 times e to the negative 0.089 times 55. and then you're going to change it to 58. Should get 43.3 and 42.2. Says at this decay rate, when will the percent of adults married be 34%? So we want to know when our equation is going to be equal to, we want to know what T is when this is 34. So we would divide by 70.7. Then we need that T to come down. So we know that we can take the natural log of 0.480905 on both sides. And that's going to allow that exponent to move down front. So negative 0.0089 T times the natural log of E. This is 1. So we don't really need it there. Multiplying by 1 doesn't change anything. Going to divide by negative 0.0089. And we are going to get that T is I'm getting 82.25, and this says in what year? So we're talking about years since 1960, I think, right? 1960 plus 82. So 2042. So this was slightly different than the other problem that we had, but the same concept. So that is the test review.